Welcome back, guys, to another video on our series on the Everything app, where I try to build all the AI functions, add all the AI models into one app, so I don't have to subscribe to all these different SaaS that I'm currently on, like OpenAI and Gemini and Perplexity and so on. In this video, I will be implementing a more complex feature, which is RAG, or Retrieval Augmented Generation. What it pretty much is where I pretty much turn a PDF or a markdown file into different chunks, and then those chunks will be turned into embeddings, or what they call vector, and those will be stored in a database. And what this enables us to do is pretty much just do a search similar to Google, where it's able to find relevant information based on what I actually wrote in my query. And this is a more accurate way, and it decreases hallucinations of AI, because AI don't have to pick out the information I provided. It'll just have to do like a very objective search based on the factor that is generated from an LLM model. This is a really good way to decrease hallucinations, because what it does is every time like an AI needs information, it will retrieve it through this system, and it will always retrieve the information, the relevant information from the database based on actual sources we provide or we've added. So for example, like a PDF or like a markdown library. And yeah, those information will be retrieved by the AI, and those will be used as an actual response to our queries, and that will make it very accurate. And it will also provide citations, which we can check back to and actually see where these AI are getting the information from. So maybe like a specific chapter or a specific page from a PDF. And yeah, that'll be possible with RAG. Just to give you like a brief explanation on the pipeline we are using, this is a pretty straightforward pipeline that I've seen throughout like so many apps that has implemented RAG. There's two components to RAG, which is the first one is of course getting the embeddings from those files. So from a file or like a PDF, we need to convert the text in those PDF into chunks. Ideally, these chunks will be divided into paragraphs or like a fixed character. And what that does is enables us to actually retrieve the most specific paragraph that contains information. Therefore, we don't have to like go through a whole page just to find the actual like relevant information we want. And to do that, I'm using Redis, because there will be a lot of chunks being generated and we need some sort of queuing system. And I'm using Redis with PoolMQ on Express.js. And with those chunks will be just filled with strings from the PDFs or like paragraphs. And then those paragraphs will be turned into embeddings by OpenAI. I'm going to be using the ADA model, and it is pretty good. And there are a lot of other embedding models out there, and I'm not going to be using like the top of the line one, but yeah, for the sake of the video, I'm just using OpenAI's one because it's the easiest to implement, because of course people have better experience with OpenAI. And of course, it is also pretty fast because I'm going to be using the small model. And for the storage, so for the object storage, I am going to be using Nano, because it is open source, it's free, and you can pretty much self-host it anywhere, because it's available on Docker Compose, and that's what I'm going to be doing. And then the next step, like the next component, which would be the actual retrieval or the factor search itself. The way it works is when a user does a query, it will be, of course, just plain text. Those text will be turned into embeddings. Again, it's pretty much these same steps. The main difference is these embeddings will be used to compare the embeddings from the database, which I am going to be using pgfactor for saving all the embeddings here. I forgot to add it to this flow, but yeah, I'm going to be using pgfactor. Another ORM I'm using is from Grizzle, because that's what we have already implemented from the previous videos. And how it works is each row will have a column that is called embeddings or factor, and those factor will pretty much just store all the factors for each chunks in the row. And those embeddings will be compared to the embeddings. The embeddings saved for each chunk will be compared with the embeddings generated from your query here. And what that does is it will perform what's called a similarity search, and it's using the HNSW algorithm. I think that's what it is referred to. But yeah, you can see the full example here from the Drizzle ORM official docs. It is very straightforward, and I was able to implement it with just the code. As you can see, this is how the actual search is executed. It just does a similarity search. Yeah, it just compares the embeddings that is in the database or like in each chunk to the embedding that was generated from the OpenAI, which is from our search query. Now, the last step, which it will be just returning results, yeah, based on like your threshold. For example, if you put the threshold of like 0.5, then of course, if the similarity is less than 0.5 or 50%, it will not return the result. It will just return the results after or like above the 0.5 threshold. So that's how it works. And yeah, I'm just going to show you guys later in the video, like just to demonstrate how it actually works. But yeah, ideally, this is a really good system to implement when you are dealing with an AI system that is, for example, A really good use case for this is if you own like an office or like a, like a business where you have a lot of different files, a lot of different PDFs that you just have lying around in your like Google Drive or like any storage, and yeah, you want to go through them. But of course, if you want to just search it up on Google Drive, it's very like, it's going to be very slow at least, or like, I don't even know if it's able to do it, but yeah, it's going to definitely not be the feasible approach, because of course it's going to be slow, and yeah, there's not going to be any AI integrated into it. Whereas if we have this system, we can integrate it with an AI assistant chat, and then we can just chat with the AI, and then it'll actually connect to our database via these pipelines, or like at least this vector search pipeline, and actually does the RAG and retrieve the correct information and actually citate the information where it has gotten the, or like it citate the actual PDF where it got the actual information from to the exact paragraph. So that's how powerful it is. So that's a bit of a mouthful of explanation because it is a pretty complex concept to grasp. But yeah, I've actually already implemented all this, and I used Codespace to create the plan. And yeah, you can see I just wrote down like a prompt here, and then I selected my project, which was the Everything app. And then yeah, here's the task that it created. I just wanted to show you briefly. So yeah, I just converted the whole repo to a mono repo because we needed that boolmq worker. So I used Express.js, so I had to create a new project in that same repo. So yeah, just made a mono repo. And then we made a whole system on the RAG. As you can see here, this was the tech spec that it wrote. And what it pretty much did is it made a full-on integration with the PG Factor implementation to Drizzle, and then also the embeddings with OpenAI. Yeah, these are all the different tasks that it generated, and it has already been completed. And yeah, here's just the boolmq queuing service where it is gonna be queuing up all the file uploads and processing the chunks and turning those into embeddings and then saving it to the database. So yeah, that's enough talking about the plan. Let's just go straight into the code that it has implemented by Codespace. So here's the RAG implementation, at least the UI of it, where I mentioned there's going to be two components to it. The first one is turning the docs or the PDF or the MD files into embeddings, and it is done here where you can just upload any document. So let's actually just try it out. After I show you so this is the second part of it, which is the retrieval component, which is where I just do a simple search, like a search query with plain text. And then what that's gonna be doing in the backend is it's gonna turn my plain text into embeddings with the OpenAI LLM embedding model, and then it will just perform the similarity search with Drizzle ORM to the file that's been already uploaded here. And I'll just show you guys, just for the sake of this video, I'll show you the actual like implementation of the document chunks. So here are the chunks that I've mentioned before, which was on this step. So these are the actual vectors that was generated and saved according to different chunks. So here's an example. So this is a chunk. It's just, yeah, the chunk division or like the chunk splitting is not the best right now, but yeah, here's just an example. So from these text or like this paragraph, you could say, it generated these embeddings, and these are what is being queried to, and what is actually being compared with the embedding that is generated from OpenAI every time we do a search query. So yeah, there's a lot of chunks right now. There's more than 100. Yeah, there's like one, I don't know how much this is, like 100 something probably. But yeah, those are just from 2 files. So it's gonna be a lot more. But yeah, I'm just gonna show you an example. I am gonna be using this Python tutorial PDF because this is pretty much the only free PDF I found that is like very long. So let's just try it out by just going to this app, back to the Everything app, and just upload the document itself. So okay, this is the tutorial of Python. It is gonna run. Yep, it just went through and processed it. Sorry, it just uploaded it. It should be now in the Nano object storage, but let's see if it is actually being processed. So it is still processing. I just wanted to show you guys the actual like Nano instance that is running in my local machine on Docker, where it is actually storing my PDFs. And you can see here, there is a specific bucket for the documents, and I can just open the documents, and this is the project. And yeah, here you go. This is everything, every doc that I've uploaded. I mean, I've already deleted most of it, but yeah, it's just not synced yet to the database, but that's fine. I was just trying it out, and yeah, as you can see, this is like the example of the files that's uploaded. So if you don't know what Nano is, it's pretty much just like an S3 alternative. And the great thing about it is, of course, it's open source and you can self-host it. So making it essentially free for you to access. And of course, the privacy is a really good benefit here because we're not storing it in a third-party service. I mean, you can, but yeah, I'm just doing it locally. So let's check on the everything app and see if the document is finished being processed. Okay, so it's done now. And when you press this, it should open the Minio instance. Okay, so I'm sorry. I mean, it should open the actual PDF, which was stored from the Minio instance. As you can see here, it is the exact same PDF that I actually uploaded. So the Python tutorial PDF was processed successfully. You can see it here. And I'm just going to do like a quick test of the query and just to make sure it is correctly querying the information, like the relevant information. I am going to just see like a random topic in this PDF and make a search out of it. So just like asking a question and see if it actually retrieves the relevant information. So let's see. So this is about internet access, and I will be asking about the modules for accessing the internet. Let's see if that gets the correct information. Modules for accessing the internet. Let's see. I'll do a search here. Okay, so it is returning several results, like several chunks, and as you can see, there is the match or like the similarity match that is in percentage. So the top one should be the one with the highest like relevancy, but I am not seeing that it has information. So I think what's happening. Okay, so I see it here actually. Yeah, so I think it is actually correct, like, but it is not returning it on the very top, so that's fine. If we pass this on to like an AI assistant, it's gonna be picking that up as the actual correct information. So that's why if you see this pipeline, this is not like the ideal scenario because of course later on you need to process the actual results either through re-ranking or through like highlighting of the actual relevant information with another agent. So that's where it makes it very powerful. But yeah, just for getting citations, this is really good already. But yeah, if you want to improve it, you can of course just choose like different models. You can see the benchmarks, which model for the embeddings actually works the best, and use that instead of OpenAI's small model, because I know that's not like the best model for doing this. But yeah, this is just for the sake of the video. So since RAG is working correctly with this app and with the pipeline that I've implemented, I will be actually integrating this to our AI chat, and we'll be actually using an AI agent for it, which is I'm going to be using Cursor 2.0 because I've been using it for like the past couple of days now. I think it's 4 or 5 days already since the launch, and it is really good. I've been enjoying using it because it's so fast, and it with the extra tooling from Cursor, especially the new browser extension, or you can say like browser integration, I guess, with the Cursor 2.0. It is really powerful just for doing web app stuff, and it does have web search out of the box and all of those like different MCPs and getting access to the latest docs. That's been really nice. So I'm going to be using Cursor 2.0. I've already have the project open here. This is the Everything app, and I am gonna be working with the plan mode. So I'm going to be planning first, like I usually do. So we already have this web search integration with Search NG. And what I want now is a different toggle, or at least like a different, like a drop down to enable either RAG or the web search, or even both. And let's see, I'm just gonna plan it out. What I like to do is I just open up Cursor with the plan mode, and I just ask it, or like just prompt it the idea I have, and I just start chatting with it, and I'm iterating through the plan mode. So I'll just show you guys. I just did the first query. So this is what I wrote, and it is pretty much just me explaining that I want it to be exactly how it works with the web search. But this time, instead of doing actually like a search to the web, it is going to be using the search with the vector search to the route where it is going to be doing the RAG. And from that RAG, it's going to be returning the results from the relevant information from the database of the different files that I have. And then what it will do is it will actually process it and return and create a response based on those information or like those contexts. And hopefully it will return like the best, like very relevant information based on my docs. And here's the plan it created. And yeah, it looks pretty good. So what I like is that Cursor creates a quite detailed plan, but it is like not too detailed. So it is good just for quickly iterating through different features. And yeah, this looks good. And I have already mentioned like the files I wanted to edit and actually have the services used. And what that actually has done is it made it very quick to make this plan. And also it is a very good way to just, save on tokens, because the files that we mentioned has the most relevant information that the AI requires to create this plan. So yeah, as you can see, this is a pretty good plan. Just looking through it very quickly, and it is what I wanted. Now let's just do the first, or like let's just continue by building it by pressing build here. Let's just do that. We'll just wait until it has finished all the tasks that it has planned out. So Cursor 2.0 with Composer 1 finished the plan, and I did just a little bit of prompting to refine the UI, but the bulk of the work was finished straight away because the plan is already good enough. That's why I always do planning, because it is essentially just context engineering. And if you know the spec-driven development approach, it is like, I would say, the most consistent way for you to get like the best results from just AI coding. And yeah, let's just go ahead and I'll demonstrate the features that was added to the chat. So basically, we just implemented a full-on RAG, the full-on RAG system that I mentioned, which is like this part, sorry, this component here, to the chat that we already have here. I just uploaded a whole new document because the Python one was too lengthy, and I think, yeah, the answers weren't straightforward because it was very technical and stuff. So a better example was I just found this Antarctica traveler's guide online, which is, yeah, I think it's a pretty cool way to test it out, right? And you just to get to know Antarctica. Yeah, I just uploaded that and it processed it and it generated, a lot more chunks. It was about like 100 chunks or so. But yeah, that's good. And I just did a quick search, and if you see, let's compare the results with the actual page that mentions this. If I can find it, I don't think I can. Okay, it's right here, and basically it just mentions like what this the attractions you can find in this location, and yeah, you can also see. Let's just see how the assistant actually handled the information. So how I implemented this was I actually added some sort of re-ranker where another agent works as re-ranking the results that it retrieved from the RAG. And you can see here, this is very relevant to my query. And the reason is because the information as cited below here, you can see it is actually getting the most relevant information based on the re-rank. So it's working really well. You can see here, it is showing the attractions from the actual location that I asked. The formatting isn't the best, but that's typical because I didn't really implement any sort of like sanitization or like formatting when processing the PDF. We could do that with like LangChain and other different libraries. It's a whole different video because it is very detailed and complex. And yeah, that's how it is. They have different like similarity scores, and that's why they rank lower here. And the top one is of course the one that actually mentions the attractions or like the actual location itself. So I know because I asked what is available or what can I do there. It just no, because from this page, you can see it has the top attractions. As you can see here, this was the original page. That's how RAG works, and that's how we can implement it into AI systems or specifically AI chat systems, which is very nice if you have a very large knowledge base on PDFs or markdowns or even docs and yeah, like a whole bunch of different other maybe PowerPoints or like Excel files. This can pass it pretty much. To wrap up the video, that's how I implemented RAG, and that's how I usually implement RAG on other systems. And yeah, ideally you wouldn't want to use OpenAI embeddings, but yeah, you can try it out yourself, which one works best, especially on your language of choice. This is using English, but there's a lot of different models that support other than English. And of course, if you speak other than English, you would want to implement those models and yeah, just try it out for yourself. And this is, I would say, like a really good stack for it. And yeah, just using PG Factor is enough, but if there are other options out there, but this is like the simplest I found to implement PG Factor or like factor embeddings storage. And yeah, like usual, I really highly recommend planning before you do any execution with AI coding. And yeah, Cursor 2.0 is the goat right now. Yeah, I really like the plan mode, and like Composer 1 is really good. And if it gets stuck, I can just switch out to a more powerful model like Claude Sonnet or even GPT-5 Codex. And of course, if you want to do planning specifically or like getting tech specs, generating a lot of different tasks at once, you can do so with Codespace. The link's in the description below. We also have a channel on Discord if you would like to discuss with us about AI coding in general or any specifics or like comparison with different models that we've used or different tools that you want us to recommend. You can discuss with us in the Discord channel. And that's it for the video. Thank you for watching.